Let's talk about some things that happen at plate boundaries. We talked about the three types of boundaries, but there are different types of crust that can interact with each other at these boundaries. So let's look at some processes and features that arise from boundaries hitting each other or separating or sliding across each other. Now remember, this is a video. You can pause and rewind and rewatch. You should have out this note sheet. I made a note sheet for you to take notes on. Okay? So plate boundaries. What happens when plate tectonics interact? So you know that there's convergent, divergent, and transform boundaries. Of course, convergent when they smash into each other or connect. Converge, divergent when they split, transform when they slide past each other. Let's start with divergent boundaries. So we have two different types. Divergent, when they split, can happen between oceanic plates or continental plates. Okay? Now, on continental plates, the process that is happening here, we call this mid-continental, sorry, my handwriting is terrible, mid-continental rifting. All right. Now, this happens when the plate split apart from each other, and what happens is a big valley forms. One of the features is a rift valley or a rift valley. That's that thing right there. Now, the cool thing about this is that as it rains, that can fill up with water and become a lake. And eventually, if the plates keep diverging and going apart from each other, it can turn into an ocean, which is how the Atlantic Ocean was formed. Also, a couple other features that you see right here and here, we have volcanoes. Since the plates are separating from each other, causing weakness in them, magma can well up and can come out of these volcanoes, as you see here, and make some new land. The next type of divergent boundary is oceanic. We call this literally seafloor spreading. Do you know why? That's because the seafloor is spreading. Now this happens under the ocean, so as the magma or lava comes up out of the mantle above the crust, it hits the ocean and cools down. So some features we get mid-ocean ridges. We also get some undersea volcanoes. As you can see, when the magma pours up and solidifies, and then the plate moves over and lets more magma up, we can have different size of ridges. Now, some of these actually, if there's weak spots next to the divergent boundary, can actually be volcanoes and create some new land, which is how Iceland and the Azore Islands was formed. Now let's talk about convergent boundaries. We have oceanic crust hitting oceanic crust, continental crust hitting oceanic crust, and continental hitting continental. So here we have continental. We call this a continental collision. Whoops. That's okay, it's just going to be one big I there, collision. So what happens is, since continental crust is usually about the same density, when these two continental crusts crash into each other, they will not make any volcanoes, but they will just kind of crumple up on each other and form mountains. Now these are non-volcanic mountains. That is a feature here, non-volcanic mountains. And some of these can be very, very, very tall. Yeah, the Appalachian Mountains actually were like the tallest mountains in the world, but they have since eroded because they were formed a long, long time ago. What can also happen is continental crust hitting oceanic crust, continental plate hitting an oceanic plate. Now what happens is that oceanic plate, as you know, made mostly of basalt. That continental made mostly of granite. The oceanic one is more dense. So what's going to happen when they smash into each other is the continental plate is going to stay up, and the oceanic plate is going to do something that we call subduction. Like a submarine, subduction. That is the process here. The process is called subduction. Now from this, we get a lot of different features. As you can see here, we can get deep sea trenches. A deep sea trench, which is right here. Remember, it's not just subducting here, it's this whole plate going underneath the continental plate. And when that happens, we also get earthquakes. We get volcanic mountains. And we can get volcanic arcs. A lot of the mountains on the west coast of America are made just like this. There's a huge subduction zone in the west coast, and we have these mountains, these volcanic mountains that form from that. We also have oceanic convergent boundaries. You might think that they'll make mountains. However, there's always, in this situation, an oceanic plate hitting an oceanic plate. One of them is going to be older, which means it's going to be more dense as it sits under the ocean for a long time. So the more dense one is going to subduct. That is just like the previous example. We get all the same features, except this one happens in the ocean. So the process is also subduction. And we still get volcanoes, which can become volcanic island arcs, because once that volcano comes up above the water, that's why we call that an island. We also get the deep trenches, earthquakes, and of course, something I didn't mention before, tsunamis. Huge waves from the earthquakes. That does also happen here. You get tsunamis that can hit the coast. Talk about transform boundaries. There's continental, continental, oceanic, oceanic. And these are relatively the same no matter what. We can call this process like sliding past each other or lateral plate movement. And pretty much what you will get a fault line. That's one of the features. Also, as you all know, if the plates are ever moving, we're always going to get earthquakes, right? And you will have this zone here that we call the fracture zone. Sometimes these zones can kind of look like rifts, but they're technically not rift valleys. If you look at the San Andreas Fault, that is a perfect example of a fracture zone, a fault line. One more thing I want to mention is these hotspot volcanisms. So volcanoes can happen without being at a plate boundary. What can happen is that there can be a hotspot in the mantle, and as plates move, as plate tectonics move and drift through continental drift, that hotspot can weaken the crust and make volcanoes. Now, as the plate keeps moving, it'll make volcanoes next to volcanoes, next to volcanoes, next to volcanoes like this. The Hawaiian Islands are formed just like that. This plate moves in this direction, and as the plate moves, more and more volcanic islands are produced. If you have any questions about this, please ask me, rewind, pause the video to get the notes on that note sheet.